Good day, students. I'm back to making a video. I just wanted to let you know that this lesson is on section 6.2. It's about real applications of normal distributions. This is the spring break video. What we would have done in class on Friday, and there's a homework assignment for this as well. So make sure you're ready and willing to do that too. Okay, so to get started, let's move on. And what we want to talk about is we want to talk about the transformation formula. Okay? And the transformation formula, there we go, takes the data from any normal distribution and turns it into a standard normal, okay? So remember, just so you understand this notation, okay? First of all, the mean is going to be the mean of any normal distribution, and the standard deviation will be the standard deviation of that distribution. And so then what's X and Z? So X will stand for the data in the normal distribution, okay? And what we are doing is we are converting that data to the standard normal distribution. Why is that? Well, the way we used to do statistics and the way we still do it very often is we use tables, and all the tables are in the standard normal form because there are an infinite number of other normal distributions. And so if we just use one of them and convert everything to that, then we can answer questions by using the standard normal. So we only have to use one table, we just need to do the conversion. I'll talk a little more about this at the end of the video, but just know that this is a transformation formula. It transforms data from a regular normal set of data to a standard normal, okay? Now there's a little graphical picture we can look at this. So suppose we have a normal set of data, all right? It has a mean and a standard deviation. And suppose that we're trying to find the area less than some X value. So we're trying to find that probability. Well, what we do is we convert it to the corresponding Z-score that matches up with this piece of data. And that because all normal curves have an area of 1, they're all symmetric, they have the same characteristics, this Z value in the standard normal will have the same probability as in the regular normal data, okay? And so there's a procedure for doing this, and here's how the procedure goes. Number one, you want to sketch the normal curve. So remember I said we always want to use the pictures because they kind of guide our thinking, all right? And then you want to, if there are X values, you want to convert all the relevant X values to their corresponding Z score, okay? And then we can use a table to find probabilities, okay? And that's it. That's kind of the process. And so what we want to do is we want to do some problems so that we're used to that. Okay, here we go. Okay, So we have three problems here that we want to do. And essentially the problem says if you use the Wechsler IQ test, then the mean is 100 and the standard deviation is 15. And if you have a mean and standard deviation of 115, can you find the probability that a score on the IQ test is less than or equal to 118? So let's go through the three procedures. The first thing I would do is I would draw a graph of the procedure. And in this case, the mean is 100. The standard deviation is 15. So that's 115, 130, okay? And then over here, 85 and 70, all right? And then 118 is right here, okay? And I want to find the probability that it's less than 118, okay? So that's kind of my picture. So to do that, I want to convert this to a standard normal, where the mean is 0 and the standard deviation is 1. Okay? And that 118 is going to be somewhere between 1 and 2. How do I know? Because it's between 1 and 2 standard deviations above the mean for the test, so it'll be between 1 and 2 on the standard normal. So it'll show up in the same spot. But in order to find out what this z value is, I have to transform it. So that's step 2. So z is equal to the data value 118 minus the mean 100 divided by the standard deviation. And that is 18 over 15, which is equal to 1.2. All right. Now I can go look 1.2 up on the table. And so when we look at the table, we get 0.8849. So remember, I got to find 1.2 and then on the top 0, 0.00, so that's 1.20. And I go down, and right there is 0.8859, I believe, sorry, 8849, excuse me. And so, to write this problem out, here's the work. So now I'm going to write out the problem. So I'll go back to the color, and I would put the probability that x is less than or equal to 118 is equal to the probability that z is less than or equal to 1.2, because we did a transformation, and that probability from the table is 0.8849. Okay? Now, just so you know, I can do this on a calculator too, and we're going to come back to that. Okay? So let's go to the next problem. Okay, the next problem is the probability that x is greater than or equal to 91. So I can draw a picture of that. I have a normal curve. This is the Wechsler test. So the mean is 100. Standard deviation is 15. And I know 91 is between 85 and 100. So right about there. So the probability I'm looking for is that. Now, this means, because it's a greater than probability, I want to take the complement of that. So I want to do 1 minus the probability that x is less than 91, less than or equal to 91. and then I will subtract off this area from 1, and that'll give me the green area. Okay, so this is the proper problem format. Okay, now I want to convert this to a standard normal. So it's still a normal curve. Now the mean is 0. Now the standard deviation is 1. So my numbers are 1 and 2, -1, -2. And since this was between one standard deviation below and the mean, then I'm going to have essentially exactly the same area. And this is my z value, whereas up here, it was my x value, x equals 91. Okay? So now I have the proper diagrams. I kind of know what I'm doing. So the first thing I need to do is convert the x to the z. So I will do that. I will say that z is equal to my x value 91 minus the mean divided by the standard deviation. And so this is equal to -9/15, which is -0.60. Okay? So this becomes 1 minus the probability that z is less than -0.60. And now all I have to do is look that up on the table. Sorry, I had a little interruption. Let's finish this video. Where we were at was writing the probabilities, and so we had just written the statement 1 minus the probability that z is less than or equal to -0.6, which was the value we found here for the z-score. So now I just need to look this up on the table. And when I do that, I get a 0.2743. And when I subtract that, I get 0.7257, which is what I expected the answer to be, over 50%. From my pictures, so I feel pretty good that I've done that correctly. Now, of course, you can check all these on a calculator, and I'll show you how to do that in a little bit. All right, so next one, let's do one more. So, and this one is where you take the big area minus the small area. So the picture we're looking at looks like this. Here's the normal curve. And then it has from 112 to 124, it has a little strip like that. And if you remember, when we're doing these, what we do is we take the whole probability less than 124, and then we subtract the probability up to 112, and that leaves us our original strip. Okay, so there's our diagram. So I can write a probability statement for this. This is the probability that 112 is less than our random variable x, which is less than or equal to 124. Okay, and now we want to take the probability of the 124. That's going to be equal to the probability that our random variable is less than or equal to 124 minus the probability that the random variable is less than 112. Okay, so there's our statement we need to do. So let's go ahead and do step 2. We want to convert that to z-scores. Okay, and so if we convert it to z-scores, we'll have a z-score table with 0, And it looks like the 112 is probably right around here, and the 124 is a little less than 2 standard deviations. So this strip on the standard normal curve will be that strip. And so the z values that we want to find this z, we'll call it z1, and we want to find that z, z2. All right? And so z1 will be for the 112 and z2 will be for the 124. So we go ahead and we do the conversion. So z1 is for the 112. So that's 112 minus the mean divided by the standard deviation, which is equal to 12 over 15, which is 0.80, if you wish. And then z2 is equal to 124 minus 100 divided by the standard deviation, which is equal to 1.60, which is 24/15 or 8/5. All right. And so there's those numbers. And so our probability statement now becomes the probability that z2 is less than or equal to 1.6 minus the probability that z1 is less than or equal to 0.8. And you could have just left them as z. I just labeled them z1 and z2 because I had to find both. So now I just use my table to look those up. And 1.6 is 0.9452. And I'm going to subtract from that 0.8. And 0.8 is 0.7881. And so when you subtract those, you get 1, 7, 5, 1. So about 15% of the data is between those two. So there's an example of the 3 problems where you go through the work using the transformation formulas, okay? And we have to use, and that kind of shows all the steps, shows you how to write the probability statements and then find those probabilities. And it shows you also drawing the new picture that you need to do, okay? So now we can go backwards as well. We have to work ourselves backwards, so let's talk about that. Now we're essentially doing the same problem, and what we have here is that the mean is equal to 100, the standard deviation is 15, and we want to find a probability, or we know that the probability is like 0.91 or 9099. Let's do that, which is 0.91. But we know that it's that probability covering this area. And what we want to find is we want to find the data value that goes with that probability. So if you think about our transformation formula, z equals the random variable minus its mean divided by the standard deviation. If we were wanting to solve for x, we would do a little algebra with this, and we get z sub alpha equals x minus the mean, which is z sub alpha plus the mean is equal to the x value. So this is the formula we use when we know probability and the z value, and then we convert it to the x value. So it's backwards. On the last problem, we knew the x, we converted it to the z. Now we use the standard normal and convert it to an x value. So what are the steps on this? Well, I draw the picture. I essentially draw the same picture, but on the standard normal curve, and I want to find the z that has 0.9099 probability. Well, this is really easy to find because I can get that directly from the table, okay? And so if I go to the table and I look up 0.9099, and I see that that is 1.34, this gives me the z value equal to 1.34. And this is directly from our table, just like we did it in class, okay? Once I have that, I can go back. I have z equals 1.34. Then step 2 on the problem is to use the formula. So I take 1.34. Our mean was 100 because it was not our mean. Our standard deviation was 15 because it's the Wechsler intelligence test. And then we add the mean of 100, and this will convert our data to the x value, the random variable for the intelligence test. And so this will be equal to 20.1 plus 100, which is equal to an intelligence test score of 120.1. Okay? And that's it. We have now found the value that corresponds. Now, in this case, when going backwards, if you had a problem where you had area to the right, so say we said this probability was 0.2 over here, then what we would do is we'd say 1 minus 0.2 is equal to 0.8, and we would go look up the z value that corresponded to 0.8. All right, and that value is approximately, it's approximately 0.84. So the z would equal 0.84, and then we would convert that. So we'd say the x is equal to 0.84 times the standard deviation, whatever that value is, plus the mean, whatever that value is. And this would change for other data. But otherwise, this is the process, and that would then give us our value. So those are the two reversible problems. Okay, let's wrap this up. So to wrap up, we want to talk about how to use the calculator to do these problems. So once again, we are going to use the statements when we go hit the second key and then acquire the distribution menu. All right. What we are going to end up with is we are going to use the normal CDF, and we're going to use the inverse normal. So how do I know which one to use? Well, if I want to find a probability, I use the normal CDF. If I want to, if I'm given the probability, I want to use the inverse normal. So how do I do that? We already know how to do it with a standard normal curve, but do you know that you can use this with any normal curve? And so what I want you to do is I want you to do these problems by hand, using the tables, showing each step for understanding. And then I want you to check your answer using these calculator statements. So for instance, we did the problem where we had an x value of 118 where the mean was 100 and the standard deviation was 15. That was the first problem we did. So how would I do that with a normal CDF? Well, I would get the calculator statement, norm CDF, and then I would enter the data. Now, if you look at this, this is all the way to the left, so this is that negative infinity thing. And so I would put just a very big number, like we talked about in class, negative 99,000 up to 118. And then I could put the mean, and now the mean is 100, and the standard deviation is 15. And so I put the mean and the standard deviation of this distribution. And this will plunk out exactly the answer that you should have got by using the tables. Now, on the inverse normal, we are going to do that problem. Say we're given the probability of 0.91 here, and we want the x value. And so in the same way, we know the mean is 100 here and the standard deviation is 15. So we're going to use the inverse normal. And the inverse normal asks us, hopefully let me get this order correct. I think it asks for the probability first. So you put 0.91, and then you tell it what the mean and standard deviation of this data is. And if you do that, it will give you the x value. So x will equal, all right? And here it will give you the probability that x is less than 118, all right? And that's how those statements work. Now, you still have to, if you're going to use a calculator, you still have to think about, oh, if I have a probability to the right, or if I have a value to the right, so say I had the 118 here, like that, and I wanted to find the probability to the right, then remember to do that, I take 1 minus the probability to the left of 118, okay? And that'll give me the probability to the right. And so on my calculator, I'm gonna do 1 minus normal CDF. And I'm going to do the probability to the left. So I'll still do negative 99,000, 118, 115, which is the mean and standard deviation we're using. And so 1 minus the probability to the left gives me the probability to the right. And then, of course, if it's in between two values, say 80 and 110, if it's in between two values, we can just use the statement and we can just put it's in between these two values, 80 and 110, and then that will calculate it norm CDF. And the same situation applies when you're doing it to the right here. You have to think, oh, if I'm doing it to the right and I know the probability is 0.2 here, then 1 minus 0.2 equals 0.8. So I know it's 0.8. So my calculator only does probability on the left side. So I want to find the probability. I can find x by doing inverse normal of 0.8 and then putting the mean and standard deviation of whatever that problem is. So that's it. That's what you need to know to be able to do 6-2, which are actually real applications of normal distributions. Okay? So that's all I have for you. Good luck. Have a great spring break. See you later.